The universe that we live in was created billions of years ago. In the time that has passed since then, it has been responsible for the formation of millions of galaxies, our solar system, and who knows what else. Although our universe has been evolving for 13.8 billion years, the question remains, how did we arrive at this point in time? Now, fasten your seatbelts. Mostly due to the fact that we are going to revisit the past in order to investigate the history of the universe. 13.5 billion years ago. When everything first started, there was nothing. Subsequently, the Big Bang occurred, which resulted in the creation of our universe. It's possible that the situation is a little more complicated than that. To a significant extent, the origin of this cosmic event remains a mystery. With that being said, once it has begun, it will never cease. Quarks and photons are examples of particles that can be created in a matter of milliseconds. You might think of them as some of the fundamental components that go into making up the world that you know today. Later on, a few minutes later, further elements came into being. In the process of combining protons and neutrons, elements such as helium and deuterium are produced. In addition, the expansion of the universe will continue at a significant rate for the next 400 million years. 13.4 billion years back in time. The instability and tremendous expansion that has occurred over the course of hundreds of millions of years will eventually come to a halt. The construction of the first structures in our universe will start as a result of this events. Imagine these structures as the components that create our stars, galaxies, and even planets like Earth. They are the building blocks of our universe. In the following video, we witness the production of primordial gas clouds that are composed of helium and hydrogen, which are two of the components that were generated earlier. The force of gravity has been responsible for the accumulation of these gas clouds throughout the course of millions of years that have passed. As soon as they came together, they gradually became denser and denser throughout the course of millions of additional years. However, let's get this along more quickly. The year 13 billion years ago. In addition to being closer and denser, our gas clouds are also increasing hotter as they continue to grow. The sudden ignition of one of these clouds will occur when the temperature at the center of the cloud hits 10 million Kelvin. This will result in the process that is known as nuclear fusion. When the hydrogen atoms get together, they will produce helium, which will result in the release of an enormous quantity of energy. An instantaneous birth of the first star in our universe takes place. Nevertheless, this is not the only one. The formation of billions of stars from within these cosmic clouds is currently taking place. In addition, these are not merely glimmering balls of light. There is no doubt that they will play a significant role in the formation of our universe. And not every single one of these stars is the same. In the process of being born, they will develop into a variety of forms and sizes. There will be some that are enormous blue giants, while others will be red dwarfs of a smaller size. It's not just their size that makes them different from one another. There are also variations in the lifespans of stars. At the same time as some people live for tens of millions of years, others live for trillions of years. As we have been monitoring these stars, we have seen that something quite interesting has been taking place. There is no way that these stars would ever want to be left alone in space. They are interested in forming a group. In addition, it is a well-known fact that galaxies are formed when these stars, together with other components such as gas, dark matter, and dust, come together as a result of gravitational forces. It was during this process that galaxies such as the Milky Way and Andromeda were created. On the other hand, that won't happen until a couple of billion years more. 12.5 billion years back in time. Continuous expansion of the universe occurred over the course of hundreds of millions of years. The formation of additional galaxies coincided with the beginning of their intriguing evolution. As we have traveled, we have noticed that the galaxies have begun to drift toward one another, which is a pattern that we have observed repeatedly. Doesn't gravity hold a lot of significance? The formation of galaxy clusters occurs as numerous galaxies begin to gravitate toward one another. These are the gravitational structures that are the largest that we are aware of. At the same time, we are witnessing the beginning of the demise of a few of the stars that were generated in the early stages of the universe. Supernovas are erupting from their explosions. However, you shouldn't let the fact that they are passing away get you down. In order to supply the universe with the fundamental ingredients that will eventually be used to form planets and life, these supernovas represent a sacrifice that is absolutely necessary. Considering that we are discussing fundamental components, I should also bring up dark matter. Despite the fact that it does not neither emit nor absorb any light, this enigmatic substance is an essential component in the overall structure of the universe. Despite the fact that we are unable to detect dark matter, we are aware that it exerts a powerful pull that has had a role in shaping everything up until this point. The concept of dark matter can be compared to a hidden framework that has played a role in the formation of galaxy clusters and other components of the universe. Back in the years 9 billion. After this point, things begin to feel more familiar. The Milky Way begins to take shape when a number of smaller galaxies join together to begin the process. In addition, the Andromeda Galaxy, which is our sister galaxy, was also produced during this time period. In addition, solar systems are beginning to form in other galaxies that are very similar to our own. The collapse of enormous clouds of gas and dust caused by their own gravity resulted in the formation of early planets and solar systems by causing them to form bonds with one another. At this point, things are just going to get more interesting. 4.5 billion years ago. Assuming that humans have been absent for a couple of billion years, it is important to note that the universe has continued to expand during this time. This has resulted in the formation of a greater number of solar systems and galaxies, as well as vastly more stars. When we talk about stars, something that is considered to be the most significant star in all of space, our Sun, was born. Immediately following the birth of our Sun, more gas and dust cover it. These particles gradually join together to form clumps, which eventually grow in size and become more numerous. Planetesimals are the precursors to the planets that we recognize today in our solar system. Planetesimals are created by this mechanism. As time passes, these planetesimals continue to expand in size as a result of the numerous collisions and gravitational attractions that they experience. It is possible that Earth is one of these protoplanets that is emerging. The growth of it is characterized by a significant event. Theia, a body that is around the size of Mars, collides with our planetesimal, which results in the formation of what we now refer to as Earth and the Moon. The other rocky planets that we know today were formed as a result of similar collisions between cosmic bodies. We have Mars, Venus, and Mercury. The formation of gas giants such as Jupiter and Saturn is taking place in the cooler reaches of space, further away from the Sun. Now that we have returned to our rocky planets, we can see that they have a very different appearance compared to how they appear in the present day. The smoothness of them is far greater than I recall. All you have to do is wait a couple of million years more for what is commonly referred to as the Late Heavy Bombardment to take place. Significant asteroids collided with these stony planets as a result of this cosmic catastrophe. That was a significant factor in the way that they are as they are today. 3.5 billion years ago. With the passage of many billions of years, we are finally beginning to observe the appearance of life in our universe. Be careful not to get overly thrilled. This category of creatures is known as prokaryotes, and they are single-celled and simple. Even though they lack many of the characteristics that are necessary for life as we know it today, they are nonetheless a significant aspect of human evolution. There are currently trillions of them living on your body at this very moment. Soon after this, oxygen starts to show up on Earth, and eventually, multicelled species start to appear as well. The climate of the Earth is starting to take shape, and we are witnessing the initial formation of the ozone layer, which shields life from the potentially hazardous radiation that comes from space. 600 million years ago. Okay, it's been a couple of billion years again, and a lot of things have transpired in that time. In the course of evolution, Animals that were formerly microscopic have developed into creatures that have vertebrae. This marks a key milestone and serves as a predecessor to all other forms of life on Earth that are classified as vertebrates, you included. The life of a vertebrate was not something I chose. I was chosen by this existence of a vertebrate. Even more transformations take place during this period of time. The continents are shifting, and plants are undergoing evolution. 200 million years ago. At this point in time, reptiles and Pangaea have lived. Having said that, it did have certain drawbacks. A catastrophic catastrophe of mass extinction takes place, resulting in the annihilation of the great majority of the species that have been painstakingly evolving. This paves the way for the appearance of dinosaurs and mammals in the future. The end of this age marks the beginning of the fragmentation of Pangaea, which lays the foundation for the modern continents that we have today. In the present day. And here we are presently. Humans have come and evolved over the course of the hundreds of millions of years that have passed. Modern civilization has been born, and now we are looking to go forward once more. Who knows what the next step will be? Travel via space? The changing climate? Technology of the future? When we travel 1 billion years into the future, I suppose the answer will be revealed to us.